Hello everyone, welcome back to this session. So I'm Timothy. We are going to talk what for a problem related to Poisson distribution. So these problems involving finding a conditional probability and determining the type of distribution related to the solution. To the solution. So in this problem, we are given two independent Poisson random value. Yeah, this is two random Poisson value. So x follow a Poisson distribution with a parameter of 2, and y follow a Poisson distribution with a parameter of 3 here. This is lambda. This is lambda. Okay. So lambda is mean that how many times will appear. So in the Poisson distribution. So so we are tasked with finding the conditional probability, but that x is equal a, and given that the x and y equal b, okay, where both are a and b are integer, and a is less than or equal to b, okay. So we also need to describe the type of possibility distribution isolated with this result and identify this parameter. So we need to find a probability distribution model isolated with, yeah. So first of all, we have to talk about how to approach to this problem, right? We are asked to compute a conditional probability, but the definition the conditional probability of a event A given event B, yeah. So is probabilities of A and B happen together divided by the possibility of B. So we have to write down the definition of the conditional probability. So this is our definition of conditional probability. So the conditional probability is given by the provision of A is intersecting with B, and then no, this is a given is event A given event B. Sorry, this is a A intercept B intersecting B, and then divided by the probability of B. That's a divide. So in this case, A is the event that x is equal A, and B is the event that x plus y equal to B. So right here. So so we have to since x and y are independent Poisson random value, so the joint possibility can be calculated as the products of their individual probability. So we move on to calculators. So we need to write down that, for example, x plus y equal b. We need to write it down there, and then x equal a. So that this is lambda. This is lambda. So that how to do. So we can write it to this first, make it simple, because equal a, x plus y equal b. So we can write it like that, right? So x plus y equal b, and equal b. Okay. So okay. So simplify this. So this is a p equal a, px equal a. So here, because because here is already mentioned that uh, x is a in this situation. So we can, I think we can do these things. So y equal to b minus a. Okay, we swap in here. We swap here. We swap the x into other side, and x is equal b under this event given the event. So so here, so over the x minus b. Okay, so we can continue to calculation. So equal to, we have to write down the equation of the uh, Poisson distribution. The equation of the Poisson distribution is this is lambda x. Okay, so here we continue. So here is a e is a minus 2. This is 2. This 2. This is a because x equal a, so this is a is factorial. So and b minus a is b minus a factorial. So over the, this is e by b factorial. Okay, so we simplify this form. So here this can remove. Okay, so we can write it like that. B, so we can continue deep down to, we can write it over to b factorial here. Continue here. Okay, this this thing actually is, okay, we can write it like that. Okay, so this is something like that. So these things can transform into the c and b, right? So and then here is 85. So you find that this, from this equation is very similar to the binomial, right? Distribution. Okay, so because the question is to describe the probability distribution, so it's a biological distribution. It's very similar to this. So this is a Poisson Poisson distribution formula. Okay, distribution form yeah. No. Okay. So I think it's all is today. So so in conclusion that the conditional distribution of x equal a given that the x plus y equal to b for a our binomial distribution. Okay, so the number of the child is b. Yeah. So and the probability of success p is lambda 1 divided by the sum of the lambda 1 and the sum of the lambda 1 and the lambda 2. Okay, so 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 we can write it like that. So the number of child and can be B, and the probability this is probability. So where lambda 1 equal to lambda 2 equal 3. So this is um, so this is the final answer that the distribution is polynomial. So thank you for your watching. So I will see you next time. Bye bye.